So now we will see one application of comparison instruction. Our aim is to find out larger number between two 8-bit numbers. And let us assume that we have two numbers in memory, and whatever result we find, so among these two numbers, whichever is larger number, we will store that number again in the memory. So for this, let us assume this is our memory area. This is our memory. In this memory, this section of the memory belongs to our data segment. Now the offset, this memory data segment is of 64 KB. So there are various memory locations, and the offset address of these memory locations are of 16-bit, and it is like this: 000H, 0001H, 0002H, 0003H, like this, F, H. So these are the offset addresses. Of various locations of data segment. Let us assume to initialize where exactly our data segment is, we are having the data segment register, and let us assume it is having a value 2000H, right? So now our first data, let us assume from the location, at the location 2000H colon, or we will take this 2000H colon 000H. At this address we have our first number, right? Our first number is here at this location. Here we have first number. And so see, when we write, again I repeat, I already discussed, to find out the exact physical memory location of this particular place, we require two things: the data segment register value and offset value. So the way we write these addresses like this, here this first we have to write the value of data segment register, and after that it is offset, right? Now our second number is at offset 0001. So at 2000H colon 0001H, we have our second number. And which one is the larger number? Whatever is the result we will store at offset 0002. So here we will store larger number, right? So larger number we will store at 2000H colon 0002H. Here we will store larger number. So now to perform this operation, we will try to write a assembly language program. First we will initialize our data segment register. For that I will bring the value which we will require to store in data segment register in AX register, AX, 2000H. Now from AX I will transfer that value to DS register, data segment register. So move DS, AX. Now I will store the offset address of my first number in some register, right? So I will use SI register for that, source index register for that. So for this, move SI, 0000H, right? So this is offset address of first 8-bit number. Now the offset address where I will store our result, that is 0002, this I will store in another register, and I will take a register DI, destination register. So move DI, comma 0001H, 2H, 0002H, right? So this is the offset address of memory to store larger number. So this program, after this, what we can do, we can bring one number in AL and we can compare, but I will use one counter also in this particular program, so that if we have more than two numbers for the comparison, then same program I can use there with slight variation, right? So now I will use one register, that is CX, and in this register, since in the particular logic which I will use to write this program, in this logic, if I am comparing two numbers, then I will keep the value of CX less than that is 1. If I will compare 5 numbers, then in CX I will store 4, right? So since we are comparing here two numbers, so in CX register I will store 0001H, right? So CX acts as counter to tell the processor that comparison of all the numbers are over. After this, I will bring my first number in AL register. Since we are comparing 8-bit numbers, so I will store the first number in some 8-bit register. So we can use any register, any general purpose register. So here I will bring the first number whose address is in SI register, right? In AL. After this, I will bring the address of my second number in SI register. In SI we have 1000H, so I will increase the value of SI by 1. So it will become 0001, which is the offset address of my second number. So here I will write the instruction INC SI. Now here I will use the instruction compare. Compare value of AL with the content of the memory whose address is in SI, in data segment. So comparison will take place. After the comparison, your carry flag will set or reset. Since here we want to find the larger number, so what I will do, I will write here instruction jump no carry, right? Jump no carry ahead. If no carry is generated, then program sequence will come to label ahead. We will explain about this. And if carry is generated, then program sequence will not go to the label ahead, right? It will execute an instruction written after JNC. So here I have to write some instruction. And if no carry, then program sequence will come here. And here I will write the instruction loop repeat. And for the repeat, the label will be here. This. And here I will write the instruction move AL, comma, within bracket SI. And in the last, move within bracket DI, comma AL, and finally we will stop the program by INT 21. This is the program. Now we will see step by step what will happen now. Let us take one example also. Let our first number is 42H and our second number is 33H. Right? These are the two numbers. So first number is 42H. So first number is 42H and second number is 33H. So now with the first instruction, AX will be initialized with 2000 and value of AX will be transferred to DS. So DS will become 2000H, right, which is required. After this, move SI comma 0000. So SI register will now store 0000H. Move DI comma 0002H. So DI will have now 0002H. Then move CX comma 0001. CX will have 0001H. And after this, move AL comma within bracket SI. In SI we have 000H. So this is the offset address of the data segment register data segment 2000H. So from 000H offset, one 8-bit, so one number will be moved in AL register. Since AL is a 8-bit register, that's why 8-bit number will be moved in AL register from the offset 0000. So with this instruction, the value of AL will become at 0000 offset we are having a value 42. So this 42H, which is our first number, will be stored in AL register. Now INC SI, it will increase the value of SI by 1. So SI previously it was 0000, now it will become 0001. After this, comparison instruction. Comparison between the value of AL register and the value of memory whose offset address is in SI. So with this instruction, value of AL will be compared with the content of memory whose address is in SI register. This comparison will take place. So we know that in AL register we have 42H and in the memory whose offset address is in SI. In SI what we have? 0001. So at this offset, whatever is the number, that will be compared with 42. So at offset 0001, what we have? 0001, this is the offset. At this offset, we have a 8-bit number 33. So here 33H. So 42H will be compared by 33. So basically minus operation will be done by the processor and result will be discarded, and depending upon the result your carry flag will set or reset. So here, since we don't require borrow to perform this subtraction, that's why your carry flag will be 0, right? So after performing comparison instruction, your carry flag is 0, right? This means it is not, it is no carry, right? There is no carry. So whenever there is no carry after the comparison in this instruction, this means our larger number is in AL. That's why carry is not generated, right? So after this instruction, JNC instruction will be executed. So jump no carry. If there is no carry, go to ahead. Program sequence will now come to level ahead. And here we have written instruction loop. So loop will decrease the value of CX by 1. If CX is not 0, then go to the level repeat. And if CX is 0, then it will come out from the loop and next instruction will be executed. So with loop instruction, value of CX will be decreased by 1. So in CX we have 0001, so it will decrease by 1, so it will become 0000. Now the value of Cx is 0. That's why program sequence will not go to the label repeat. It will come out from the loop and it will execute this instruction. Move within bracket di, comma al. Whatever is in al, that has to be stored in the memory whose offset is in di. So what is there in al? In al we have 42, which is the larger number, right? So this 42 will be stored in the memory whose offset is in di. At di we have 0002. So this is this offset 0002. At this offset, result 42H will be stored. So here at this offset 42H will be stored. So in this way we find the larger number. Now you say, again we want to find the larger number, but now you just think about a case when at first offset we have 33H. Here we have now 33H and here we have 42H, right? If we change the sequence of the number, first we store now 33H and now we store 42H, right? 42H. So if we change these number sequence, then whether this program can find out the larger number, we will check this. Okay, so again with the first two instructions, ds will become 2000. Move si, comma 0000. So si you make 0000. Offset address of our first data. Di, move di, comma 0002. Where we want to store our result, that we will store our offset address in di. Move cx, comma 0001. In cx we store a value which is 1 less than the total numbers which we are comparing. Then move al, comma within bracket si. So in si we have 0000. From this offset, one 8-bit number will be moved in al. So at this offset, now we have number 33. So al now we have 33H. Then inc si. We will bring the address of my second number in si register. So si is increased by 1. So this is 0001 is the offset address of my second number. That is now in si. Then comparison between al, comma within bracket si. So again this comparison will take place here. But now here numbers are different. In al we have 33H. And the second number is in memory whose address is in SI. So in SI we have 0001. So this is the offset address 0001. Here we have a number 42. So now comparison will take place here between 33 and 42H. So during the comparison, this minus operation will take place. Result will be discarded. And in this subtraction, since we are subtracting 42H from 33H, so borrow is required. If borrow is required, then carry flag will become 1. It will set. So now after the comparison, our carry flag will set. This means there is carry. There is carry. So if the carry flag sets, this means that when we are comparing AL with this number and the carry flag sets, this indicates that whatever is there in AL, it is smaller number, right? Now we will see next instruction, jump no carry. Means if no carry, then jump to ahead. But carry is there. If carry is there, then don't go to the ahead. Next instruction after JNC will be executed. So now what this instruction will do? It will transfer the larger number, because our larger number is in memory whose offset is in SI. That number will be transferred to AL. So this instruction is executed. In this instruction, what is the value of SI? SI is 0001. So at the offset 0001, some 8-bit number will be transferred to AL. So at this offset, what we have? At 0001, we have 42H. So 42H will be transferred to AL. Now the AL value, which was earlier 33, it will be changed to 42H. Now larger number will come to AL. After this instruction is executed, loop. It will decrease the value of Cx by 1. So now Cx will become 0. Now if Cx is 0, then program will come out from the loop and this instruction is executed. Move within bracket di, comma AL. So in AL what we have? 42H, which is the larger number. So it will be stored in the offset in the memory whose offset address is defined by di. In di we have 0002. So at 0002 we get 42H. So here again we get 42H. So in the both the cases, whether the larger number is at a smaller offset or the smaller number is at a smaller offset, this program is able to find out the larger number among two numbers. Right? Now what we will do? Now in place of two numbers, right? Now we have suppose three numbers. To find larger number among three 8-bit numbers, we have increased the number, right? So now whatever program we will write, same program we can apply for whether the three numbers, whether we are having 10 numbers or we are having 100 8-bit numbers, we can apply the same program. Slight modification will be here. So now first number is at the same address, okay. Second number at 0001. Now the third number is at 0002. So here now we have a third number. Right? Let us assume that number is 40H. Right? And we will store the result at offset 0003H. At this we will store the larger number result. So here we have our first number and first number is 33H. Then 0001 offset we have second number. So here we have second number is 42H. At 0002 offset we have our third number and third number is 40H. And at 0003 offset we have result, that is larger number, that is our result, right? So in this program, let us see how we will find the results. So you do the initialization, first two instruction is same, because for the DS register we have to load 2000. Then move SI, this is the offset address of my first number, that is also okay, offset address of my first number. Then move DI, in DI register we will store the offset address where we want to store our result. So now the offset address where we want to store the result is 0003. So this I will change. This will be 0003H. Now CX. So here in the CX we will store, since we are comparing three numbers, so in CX we will store one less than total numbers which we want to compare. So here we will store 0002, right? Now first instruction, okay, so here initially it is 0000, then it is 0002 and CX is 000, no, DI is 0003 and CX is 0002. Okay. So SI 0000, DI 0003, CX 0002. Right. Now move AL comma within bracket SI. So our first number whose offset address is in SI, it will be transferred to AL. So in AL we get now 33H. Then INC SI, it will increase the value of SI by 1, so it will become 0001, which is the offset address of the second number. Then comparison operation will take place with this instruction, comparison between the value of AL and the value which is stored in the memory whose offset is in SI. So again here the value of AL will be compared with the memory whose offset is in SI. So in AL we have 33H and in SI we have 0001. So at this offset what number we are having? 0001. We are having 42H. So here 42H. So after the comparison, result will be discarded, and in this case your carry flag will set. So carry flag will set. So once the carry flag will set, this indicates that our larger number is in memory, right? Because see, in AL we have 33 and in the memory we have 42. Now after comparison, JNC instruction will be executed. JNC, jump no carry. If no carry, then go to ahead. But here carry generated. That's why next instruction is executed. So the purpose of this instruction is always to bring the larger number in AL. So now move AL comma within bracket SI. In SI we have 0001. So from this offset, one 8-bit number will be moved to AL. At this offset we are having 42. So with this instruction, AL will become now 42H. Or larger number between first two numbers is in AL, right? But again there is a third number is also there. We have to compare this with the third number also, right? So larger number is in AL. After this loop instruction executed, it will decrease the CX by 1. If CX is not 0, then go to the label repeat. Now CX is 2, so it will reduce by 1, so it will become 0001. Now this CX is not 0, so program sequence will go to label repeat now. So program sequence will come here. Then here the instruction is INC SI. It will increase the value of SI by 1. That is, now it will 0002. And this is the offset address of my third data. Then comparison between AL and the data whose offset address is in SI. So in AL what we have? 42. So here in AL we have now 42H, and in the memory whose address is in SI. In SI we have 0002. So at this offset 0002. So there is a data of 40H. So 42H will be compared with 40H. And in this case no borrow is required. That's why carry flag will reset. Carry flag will reset. Once the carry flag will reset, after this JNC instruction is executed. Jump no carry. Carry is not there, so program sequence will come to label ahead, right? Here we have written instruction loop. It will decrease the value of CX by 1. So now CX will become 000, from 0001 it will become 0000. This means the value of CX will become 0. This means we have compared all the numbers. And our larger number is in AL by this time. So program sequence will not go to the label repeat. This instruction is executed. Here move within bracket DI comma AL. So in AL what we have? 42. It will be transferred to the memory whose address is in DI. In DI we have 0003. So at the offset 0003, 42H will be stored. So we get the larger number now in at that particular memory location. In this way, among the three numbers, this program is able to find out the larger number. Now suppose we have a series of 100 numbers, then simply change only this counter. Right here, 100D. The equivalent hexadecimal value of 100 calculated and loaded in CX. Same program will find out the... See, in Excel sheet, in computer we have the Excel sheet. And in the Excel sheet there are various data. From the various data we can find out which number is larger. So basically in the background, this type of program is there, right? This type of program, when we use that function to find out the larger number, so basically in the background there is this type of program. It find out the larger number and it will be displayed, right? So this is the program to find out the larger number from the series of 3 numbers, and you can convert this program to find out the series of any numbers. So here I will write 0002. Right? Now simply what I will do, okay. Now if in the same program, in place of JNC, if I use the instruction JC, right, then this instruction will find out the smaller number. This instruction will find out the smaller number. Only if we change this instruction, that's all. If you find out the smaller number, change this instruction. So you try to take 3 numbers, same 3 numbers, right? And in place of JNC, now you use JC, right? Then one by one, step by step, you execute the instruction. Then you will find that you will get the smaller number at that particular memory location, right? So you try that. Now what simply I will do? I will write the same program by using directives, right? So by using directives, I will write the same program. So for this, there is a slight change, slight addition we will do. I will write here, assume CS colon code comma DS colon data, right? Then data segment, right? Then N1 DB, and our numbers are, suppose these are the numbers 33, 42, 40. 33H, 42H, 40H, right? Then for the result, I will use N2, DB, and result is unknown, right? Because if we change the numbers, then some other result may come. That's why we don't put any value here. And after this, data and segment, right? After this, we will start code segment. So for the code segment, right? And then we will write the first instruction, move AX, comma, and now here I write data, right? In place of this 2000, I write data, because automatically our assembler will take care about which particular memory segment will be allotted for the data segment, right? And here I write start here, right? Okay, this instruction is okay. Then for the source, right? The offset address of my source. Here we have specified that our offset address is there. So our assembler will take care. It will assign any offset address which is available in that particular memory. So for this, I will write here offset N1, right? Because for our source of the data, this is N1. For the destination, I will write offset N2, right? Then move this, INC, this, okay. And in the last, I will end the code segment. So for this, code and S. After this, I will end the start. So for this, end start. And in the last, end. That's all. So this is our program. If we write this program in any software, then it will give you the result. So if you want to write a program to find out the smaller number, then simply change JNC by JC. You will get the smaller number.